Hey, welcome. Today we're going to be talking about infrastructure as code using Azure Native's tools. And in this case, that's going to be Azure Bicep. There are a lot of approaches to infrastructure as code. You've probably all heard of Terraform. Terraform has its place, it has its merits, but an alternative is Bicep. And one of the advantages of Bicep is that it is a tool that is provided by the Microsoft team that owns the APIs that it runs against. So you're very likely to have a very smooth experience using this tool against Azure, which is, I believe, one of the reasons that if you're only working on Azure, this is probably a very, very viable choice for your infrastructure as code. If you're wondering who am I, my name is Henry Been. Most notable fact about me, I live on the island of Texel. So I left this morning somewhere around 9, and I was here a little bit past 12. So that's my life traveling up and down the country. If you have any questions or remarks, feel free to reach out during the talk or after the talk, and I will try my very best to answer them. I have no problem with questions from the audience. There's a camera in the back, but I'm here for you. And if we can make this a conversation instead of a presentation, I'm all for it. The goal of today is for those who love this fantastic, beautifully designed portal that for some reason uses horizontal scrolling instead of vertical scrolling. If you like it and you love it, we're going to be trying and getting rid of it for building our stuff in Azure. We're going to use it for reading a little bit, but no more clicky-click and infrastructure creating throughout the portal. And I hope that by the end of this talk, you are confident to try and get rid of the portal for creating infrastructure as well. And in your production environment, hopefully have no write access to your Azure infrastructure at all, which is also a great security benefit. Now, in case you're wondering, is this whole infrastructure as code really a thing that we should be adopting as our team? I think it's yes. And there are a few reasons. I'm going to iterate very quickly upon them, because we don't have much time. But one of them is the loss of configuration drift. If you have been working in IT for quite a while, you're probably familiar with the fact that if you have 7 servers in your production environment, and you look very closely at them, none of them are configured in precisely the same way. Updates have been applied in a different order. An update has been rolled back on one of the machines because it gave problems there, and it wasn't reapplied. One of the machines was replaced 2 years into the project or product, and it has a new version of Windows. And at some point, your application will break on one of these machines because there are differences between them. And what is the reason? Manual changes. Infrastructure as code will automate all the changes to your infrastructure, getting rid of that problem. The second thing that you can get out of infrastructure as code is that once you have written your complete infrastructure as code, there is almost no additional cost with creating 1, 2, 20, 100 more environments. At least developer time. There's probably going to be cost with your cloud provider or your on-premise data center, but the creation of a new environment is going to cost you virtually no time. And if you want to run tests against a fresh environment, that's a great benefit. Thirdly, stuff is repeatable. Let's say you're rolling out version 84 of your infrastructure in production, and it's working great. And then you roll out version 85, and it's a big mess. And you want to go back to version 84. That's pretty doable and pretty reliable with infrastructure as code. Try doing that manually. Infrastructure as code, as it is code, is human readable. That means that it can be stored in source control. It's reviewable. You can see the change history. You get all the perks of code, just as with pipelines as code, if you're using those. You can do 4i reviews. You can do sign-offs. Managers love those. That's fantastic. But if you really think about it, it makes that all the things that we know about deploying code from a DevOps point of view can also be applied to your infrastructure. And I think that's the reason you want to adopt infrastructure as code. Now that you're sold on the ID, let's see how we can do it in Azure. So in the old days of Azure, like over 7 years ago, over 8 years ago, if you wanted to create infrastructure in Azure and you didn't want to do that in a portal, you had to write PowerShell, and it was imperative. But at that point, a declarative approach was introduced. It was called ARM templates. ARM stands for Azure Resource Manager. It's the REST API you interact with whenever you make a change on the control plane in Azure. Create a resource, update a resource, delete a resource. All the things that you used to phone your IT department for and then wait for 6 weeks. That's replaced with ARM templates. Now, ARM templates were written in JSON. And that's one of the reasons people didn't really like them. The syntax is very cumbersome, and basically it doesn't work if you're going to do a very big project, unless you really dive into the nitty-gritties of that language, which nobody wants to do. So it is replaced with something else, and we call it Bicep, because what powers ARM? The Bicep. So for your reference, this is an infrastructure as code approach using an ARM template to create a storage account in Azure. Now don't try to understand this, because we're going to get rid of it, but look at it and you just, feel that pain of having to type that JSON schema. Feel the pain of having to write all those quotes and curly braces and commas and double quotes, and just compare it to this. This is Bicep. If you have been working with ARM templates in the past, but you haven't tried Bicep yet, I hope you will leave with tears of joy by the end of this session, because it's going to be a major improvement. You're going to have much less noise with commas and all the stuff that's just ceremony. And the other thing is that's probably going to trim down your templates by 50% or more. So that's just less typing, but also less reading. Now, let's say you want to write a Bicep file like this, and you need to actually create stuff in Azure. How do you do that? You download a command called Bicep, you run Bicep build, point to the file, and it transpiles it into an ARM template, because the API still runs against ARM templates instead of Bicep files. Once you have done that, you create something like a resource group or a subscription or whatever you want to deploy resources to, and then you create a new deployment from the ARM template. This is if you're running on the CLI version 0.21 or lower. If you're running on 22 or higher, 0.22 or higher, you can now skip the builds tab and deploy a Bicep file directly. This will invoke the Bicep transpiler on your local computer and then push the outputs directly into Azure. That being said, I hope this gives you a little bit of an overview of what we're going to do. But what I really want to do is just show you. Hopefully we have about 35 minutes left. And what I want to do is, first of all, save you from this animation. Oh, funny story here, by the way. I bought that animation 5 years ago when I did my second presentation on the conference. I'm really Dutch, so I'm reusing that all the time because I paid for that. True story. So what we're going to do, we're going to open Visual Studio Code. We're going to create a new empty file. And we're going to start creating an infrastructure in Azure from scratch. And hopefully I can take you along on that course and explain the syntax while we go. And in the end, we have an architecture that's capable of running something like a web app or a web API, has some application insights attached, and is in principle ready to take home and try on your projects tomorrow. And if you have any questions or stuff, at this point, feel free to interject. Because, I'm here for you, not just to do a show. Any questions so far? Right. Let's try this. So what you're seeing here is Visual Studio Code, which is, an attempt at recreating Visual Studio proper. I don't really like the tool. I'm a fan of Visual Studio proper. But for Bicep, Visual Studio Code works much better. And one of the reasons for that is that there is an extension called Bicep, which gives you great autocomplete syntax for your Bicep files. And my mouse is not working. That's a bummer. So the extension I already installed here, but you can find it when you type Bicep, pops up, you install it. It's from Microsoft, so it's trustworthy. Now let's start creating a new file. And I'm going to call it, let's call it demo.bicep, because I'm not very fantasyful. And one of the things that you notice here at the bottom right is that it's detecting that's a Bicep file, and I can start creating my resources using this syntax. Now, one of the most important keywords is the keyword resource. I use it to declare a new resource. And what I want to start with is an app service plan. When you want to host an API or an app service in Azure, you're going to need two things: the app service plan and the app service. The app service plan is an abstraction of the underlying compute. Let's say that forbidden word, VM. And the app service is an abstraction of the IIS side that runs on that VM, so you can have more than one app service on a single app service plan. So we need to start with the app service plan. So let's call it my app service plan. And then every resource in Azure is of a certain type. The type that consists out of at least two parts. The first part is what we call the resource provider. That basically aligns with a team or a group of teams in Azure that is responsible for that service. And then the parts after it that specify the specific service. In this case, we're looking for Microsoft.web/server farms. So the server farm is the technical name that underlies the app service plan, because it used to be called app service farms, and you're not working at Microsoft if you don't rename something every other year. So they renamed that to an app service plan, but for backwards compatibility, the underlying name is still service farm. Now you see that the name has to be, put proper, because otherwise you get squirrelies. And we also see an @ sign, because we have to specify a version of the API that we want to use to create that app service plan. Now, I should be able to invoke tab or control space autocomplete again, and as a reflex, I select the latest version. Now, of course, I have to specify properties for that plan. I do that by putting in an equal sign and then open curly braces. And then I can start specifying properties. Every resource in Azure needs a name. So that's the first one that I put in. Let's call it, I don't know, my to-do app service plan. You might be a little bit confused by now. Why do I have my app service plan here? And why do I have a name here? That's because they're two different things. The property name is the name of the resource in Azure. The one that you see here at the top is a symbolic name. That's the name that I can use to point to that resource within this file. Especially when we start getting into generating the names of resources, that name within the file is going to be a constant that we can continue working with. Besides the name, which is part of the identity of the resource in Azure, we're also going to need to specify a location, which is West Europe. Now, and then we're going to need at least one or two other properties for an app service plan. And at this point, you might be wondering, where do I find all these properties? So there are three things. You can go into your favorite browser, say not Edge, and search for mtemplate reference, ARM template reference. And then, unless when you're using Bing, the first result is always going to be, wow, there goes my, yeah, okay, there we go. It's going to be this result. Here on the left, we see all the resource providers in Azure. Yeah, sorry, I was, getting completely out of the flow by this green block that I didn't expect. Here we see all the resource providers. For example, the one called Web that we've been using. And here we can find the different resources. For example, Service Farm. And then we can see all the properties that we can specify. We will also see in a bit how we can reverse engineer them out of an existing resource. And there is another trick that you can do, which is Microsoft.web/server farms. And then resource, I think. No. There is a automatic completion to give you all the required properties for that. Sorry? There it is, required properties. Well, and it says it's only name and location, and that's actually not true. You need one more, otherwise it's going to fail. So the third thing that you can do is take notes. But I'm very forgetful. So one of the things that you need to do when you make notes is actually bring them to your presentation. So the one more thing that we're going to need here is that we need to add a property called properties. And in the body, sorry, I'm lying. We need to put in SKU, which has one property called name, and here we put in B1. So remember when you create a service, an app service plan in the portal, you have to specify which kind of compute you want, B1, B2, B3, S1. You have to specify it here as well, and these are the properties. If I now save the file and create a new resource group in Azure, AZ group create, resource group, demo, location, West Europe. I can say AZ group, AZ deployment group creates to the resource group demo template file, what was it called? Demo at Bicep, and now that resource is being created in Azure. And of course, you can invoke this from your pipelines as well as an alternative to from your local machine. Now, from here, we can just continue building our infrastructure. Remember I said we're also going to need an app service on top of the app service plan. I'm just going to create a new resource, my app service. And now the type needs to be Microsoft.web/sites. I have to specify a version, which is again the latest, and then its properties. And meanwhile, we see that my app service plan is created. Now for the app service, again, we're going to have to specify a name, which is my to-do app service, a location, which is West Europe. And the other thing that I need here is properties, which has a server farm ID. This is where I specify that my site should run on top of that service plan. And I need to point to the resource ID of that app service plan. And that resource is something like management.azure.com/subscription/subscription ID/resource group name/provider/Microsoft.web/server farm/the name of server farm. Now you can write a very long and lengthy expression to generate that. But one of the things that we can do in Bicep is we can reference that resource within the same template and write .id. And if you're coming from ARM templates, this is just awesome. So now I have defined my app service on top of the plan. Let's just quickly verify if everything is still working. And while we wait on that, let's try to scratch one of my itches. One of the things that I as a developer really don't like is repeating myself. And one of the things you see here is that I start repeating the location. And if somebody just changes this to North Europe and it doesn't change the other one, stuff is going to break. And if it isn't breaking, it's going to introduce a lot of latency between my resources, where a lot is very relative, by the way. So one of the other keywords that we have in Bicep is param. So let's create a new, let's start with var. Let's say I want to specify a location just once, West Europe, and then reuse that throughout the template. And now I can just say location. For those coming from ARM, I don't have to invoke that function, parameters, or variables. Just reference back directly to the thumb one. It's good to know that all parameters, which you will see in a bit, resources, and variables share a single namespace. So you can't accidentally give the same name to a parameter and a resource and then have to remember which one takes precedence. It just has to be unique. Now, this is still a squirrely because it says it shouldn't be hard-coded. So there are two ways to get around that. We can change it to a parameter. For parameters, we have to specify the type because it cannot interfere the type of a parameter if the value or the default value is not specified, which it can for a variable in the file. And I can also specify default if I want to. Another trick that I can do is use functions. Let's say I go back to my variable and say, hey, I want to get some properties of the resource group that I'm deploying to. There's a function called resource group that I can invoke. And then with .location, I can get the location of my resource group and reuse that for all the resources in the template, which I believe is quite a good practice to have all the resources in a resource group in the same location as the resource group. And if you have, for example, a geographically deployed application, you're probably going to deploy stuff in North Europe separately from the stuff in West Europe as a risk mitigation. So you're not going to mix them in one resource group anyway. Now it's still going to be complaining because there is a rule in the linter that says you shouldn't be doing this here. And just use a parameter. I don't agree. Thank you very much for the help. So people that know me know I'm very eigenwijs. How do you say that? How do you say that in English? Stubborn. Yes, stubborn doesn't begin to cover it. All right. Hey, so let's continue our infrastructure a little bit. One of the things that you need when you have an app service in Azure is a way to monitor it. And one of the resources that you can use to do that is application insights. I mean, it's not a question of if stuff will go wrong, it's a question when stuff will go wrong, and we probably want to know when it is. So let's say my app insights. Then I have to know the resource type again, which is Microsoft.insights/components. Latest version. I give a name, my app insights, and I give a location, which is the location that I already have. And now I need 2 more properties. And the first one is kind, which has to be web. And the other one is that I need a properties object, which contains an application type, which is also web. Notice the difference here, by the way. Here it knows that it has to be either web or other, and it helps me out. In the other location, it didn't. That's because all the autocompletion is generated out of the Swagger, or OpenAPI it's called nowadays, that's being provided by the individual resource providers. And not every product group, product team is as good as some others are. So this gives me my application insights instance. Now, if you're familiar with this kind of architecture, you know that we now need to go into the portal and get that instrumentation key for application insights and put it in the settings of my app service to connect my app service to the application insights. Let's not do that. Let's just forget that portal and go into my app service and create my configuration here as well. Because one of the things that I can do, I can say resource my app service config is Microsoft.web/site/config, latest version, because latest version. The name is going to be app settings, app config. What does it need to be? Maestro. Oh, it has to be the name of my app service /app config. So the reason for that is as follows. If you look at the type of this resource, you see that it has 2 slashes. This is what we call a nested resource because the configuration lives in the app service or is a child of it. And to identify where it needs to go, I also have to specify 2 parts for the name. First, the part of the resource where it is a child of, and then the name of the resource that I'm going to be configuring. And in this case, that's going to be app config or app settings. I forgot.
You can also use the parent.
There are 5 ways that I will show, or maybe 3, but at least more than 1. But you're completely right. I don't have to specify a location because it inherits the location of the parent resource. But what I do have to do, I have to specify properties, which are the key value pairs, which are going to be my application configuration. So here I can say application insights _ instrumentation key equals, and then again, either a very long expression when using ARM, or my app insights dot, what was it again? I think, nope. I have to be more specific. It has to be colon indeed, and then my app insights dot properties dot instrumentation key. So when I deploy this, there are 2 things that are happening. First of all, ARM detects that I have an implicit dependency from my app service configuration onto my application insights. So it will make sure to deploy application insights before it gets started on the configuration. Once it is running the configuration, it will see that it has to fetch that value from that resource and has to provide it here. And that secret, because I believe it should be a secret, transfers within Azure. It doesn't leave the Azure cloud. It is not pulled to local and then pushed again. It stays in the cloud. Now, of course, if you want to be even more secure, you can use a key vault. I'm not going to do it here. I'm just going to keep it in the app service configuration. Now, there are 2 different ways that I can write this. First of all, I can use a parent instead. Parent, and then, what was it called again? My app service. And then I don't have to use the 2-part name. And now it's also going to tell me that it has to be app settings. So now it knows of this parent and child relationship. Another thing that I can do, which often sparks a lot of debate, is that I can take this resource and nest it. And then I don't have to specify the parent, because that can be derived. And I also don't have to specify the common part of the name. So I can make it even shorter. If you're going to be nesting a lot of stuff, so you have a service bus that has 3 topics, all of them have 2 subscriptions with 4 authorization rules, it's going to be very hard to manage because you're going to get quite a lengthy file and it's hard to find out what's nested in what. So, pick and choose depending on your situation. Now, let's see if I have not made too many typos and see if we can deploy that into Azure. And then you have seen some of the basic things that you can do with Bicep. Any questions at this point? Yeah.
Yeah, so you've shown that you can basically build ARM. But can you also say I have a whole load of ARM templates? Can you also convert it to Bicep automatically?
So the question is, I think the room is small enough, but for the recording, if I have existing ARM templates, can I convert them back into a Bicep template, or can I convert them forward into a Bicep template, detranspile? And the answer is yes. And there is a command, az-bicep, which downloads the Bicep executable and it executes it as part of the CLI. And then there is a command called decompile that you can use. And then you provide a file, a JSON template, and you will get the Bicep file. Of course, it's going to be not as pretty as you can write it yourself, but it should be working as files can be completely transpiled back and forth. Another question that comes up a lot is, what if I have all my existing resources in Azure? Can I reverse engineer a Bicep template out of those resources? So the question is, yes, no-ish. If I go to any resource group that I've got, let's say this one, it's for a demo for tonight, I can go to any resource and then find its JSON view. And then about 95 or more % of the time, I get the JSON for that specific resource. It doesn't work always, but it works in most of the cases. But you already see the biggest problem here. You are getting all the properties of that resource, including all the defaults. And one of the things that we normally don't do when we write infrastructure as code is provide all the defaults. And the reason is that we get very, very lengthy files. So one of the things that you might have to do is strip the defaults and then transpile it from JSON into Bicep. There has been talk of automatically exporting Bicep files as well, but I haven't seen it, and I don't know if they're going to do it. Now, doing this on a per resource base is not ideal, so you can also do it for a resource group as a whole. I saw your hand. And you can go to template or export template, and you will get a template for the whole resource group. Now, be mindful, it doesn't include all resource types. So for some resources that you might expect here, it doesn't include them. Yes, there was a question there.
Yes, so just if I understand correctly, if you transpile it to Bicep from an ARM template, it leaves out the default settings, or it does include it? So, yeah.
So the question is, does it, when transpiling from a ARM template in JSON to a Bicep template, automatically strip the defaults? No, it doesn't. It is still up to you to strip the defaults, either in the adjacent before you transpile or in the Bicep after you transpile. Sorry, but it's better. So what I often do is I write them from scratch while peeking at the JSON. But of course, from experience, you know which kind of properties you need to look at. But if you forget a single value, sometimes you can get very nasty surprises. Any other questions at this point? All right, so the question is, can you validate or compile the Bicep file, or maybe something like a dry run before pushing it to the actual environment? And the question is yes. So there are a number of things that I can do. The first one is just az-bicep build, which is, of course, the opposite of decompile. But it's called build instead of compile. And then I can specify a file, and I will get the JSON file. So actually, if you're being very puristic about continuous deployment, you probably want to build it in your build phase along with your code, and then save the JSON file, and then deploy the JSON file to test into production. because if the tool chain changes between deploying to test and to production, you have this theoretical risk of having different results in production than in your test environment. It's very theoretical, but I do it. I don't know why. I've done it always. I saw another question, I think. Let's start in the back. Are there any disadvantages of Bicep over ARM? So there are two that I can think of. The first one is that if you're using custom functions, which I have never, ever seen in the wild. So if you're using custom functions, that's not supported in Bicep for now, to the best of my knowledge. And the other one is that if you're only familiar with Bicep and not with ARM, you might run into leaky abstractions when you start deploying. Because remember, we are still deploying ARM templates. So if your deployment fails, the error is going to be about that ARM template. It's going to have a line number for the ARM template, and it's going to say something that's wrong with the ARM template. So you have to be capable of finding that in that JSON file, then reverse engineering the solution to Bicep, and then fixing it there. So that's one of the advantages. However, if you remember ARM, you're probably very familiar with making a change, pushing it, getting an error, making a change, pushing it, getting an error, because the in-editor experience is not very good. With Bicep, that's very different.
I always use validate. Can you also use validate?
Yes. Yeah, like I just showed, you can do AZ Bicep build, and then you will get all the validations that are possible when you're transpiling. What you also can do, there are two other things that you can do. There is a validation deployment, so that you can use the validation mode when deploying. That's still possible. And the other one, what-if deployments are also still possible.
And are there any things Bicep can do that are supported in IAM, like nested deployments?
The question, sorry, can you repeat it? It can or cannot?
Can Bicep do it as well?
So the question is, can Bicep also do nested deployments? And the answer is yes. So that's the thing that I wanted to show as well. Yeah, because of time, I'm going to move on to what I wanted to show about what are called modules. So what you can do with Bicep is you can include other valid Bicep files as a module, which will generate a linked deployment under the hood, which is an inline linked deployment, by the way. You can also do your regular linked deployments because the deployment is just a resource. So what I've done, for example, here, is I've created a Bicep file, which is called metric_module.bicep, which is a valid Bicep file. Nothing makes this a module except for the fact that I'm going to use it from another Bicep file. What I can do, I can say module, and then I give it a name. Again, let's call it my metric alert. And instead of specifying a resource type, I have to reference a file. And I get completion, so let's say metric module. And then I have to specify some properties. The first one is the name. This is the name of the deployment for all the resources in that file. So the name of the linked deployment that you were referring to. So let's call this my alerts deployment. The second thing that I have to specify are the params. And here I have to specify key value, the values for all the parameters that are specified for this module. So, for example, my application insights ID, reflex, no commas needed. Then the alert name, let's say field dependencies. Then the metric identifier, which I think is dependency/fields. And then finally the threshold, which is of course 0, because I want to get called out of bed all the time. If I now deploy this, I will see a deployment that triggers another deployment. What we can also do, say AZ Bicep build --file demo.bicep. Now we will get a demo.json. So for those who aren't familiar with ARM yet, please close your eyes, because this is not going to be pretty. So here we see my module inclusion is translated into a specific resource type, namely the deployment. My alert deployment And I see a lot of mumbo jumbo and all kinds of ceremony that I'm not really interested in, only to pass the parameters to the nested template, which is here, specifies the parameters, and then here actually the resource that I use. So if you're using linked templates a lot, the amount of typing saved is well over that 50%. It can be as close to 60 or 66%. So those are modules. A few other tricks that I wanted to show you before we run out of time is that one of the things that you might want to do is reference existing resources. Let's just imagine that my application insights instance already exists because it is created using another deployment, and I don't want to write that very long expression to reference it by name or URL. I still want to use this fancy Bicep syntax and reference the existing thing. What I can do, I can remove everything except for the name, and then use a keyword which is called existing, which I have to also get where to, there it should go. And now I reference an existing resource. So this deployment will fail as that resource doesn't exist yet, and I am still able to fetch properties of that existing resource within my template. The other thing that I wanted to show you is conditionals. There are two control constructs that we can use in a Bicep file, and they're called if and for. If is a conditional. Let's say I want to deploy this template to both my test and my production environment, but I don't really want to get called out of bed at 2 AM when there is a problem on the test environment. What I can do, I can add a conditional here. So let's say I only want to be deployed in certain situations. And let's say we put a parameter on our file, param environment name, which is a string. And now I can say, for example, if my environment name equals prod, then I want to enable this. So that's the if. Now let's do a little bit of cleaning. One of the things that I can do here is add an annotation that's called allowed, which allows me to specify an array of allowed values, probably what you expected. And then now I'm forcing everyone to either specify test or prod when they're deploying this, and I'm enabling this rule on my production environment only. So I only get call out of bed when it's really necessary, or at least alone for my production environment. So, sorry, Erik?
You also get autocomplete now in the other places where you use code.
Yes, absolutely. You mean I don't have to write this complete name again?
If you would reference this in some other template and say resource, then it autocompletes that as well for you, which is very helpful. Yes.
I think it is yes. I don't understand yet, but yes, it autocompletes everything as soon as it knows about it. But for example, if you use it in another place as a module, yes. So that's what we saw here as well, right? The autocompletion on parameters that are declared by a file or a module. The final thing that I wanted to talk about is another control statement that's called for. Let's say that I want to have like multiple alert rules, and I don't want to copy paste this whole body, but I only want to, write it once and specify somewhere the things that differ between it. So what we can do, we can take this little bit of code, put it here, and say, hey, I'm going to create two metrics, one for field requests and one for field dependencies. I have the alert name and the metric identifier, which are these two values, but the app insights ID and the threshold, they never change. So why repeat this as a module, but just do this module multiple times? So I'm just going to quickly remove the if, and I'm going to say for metric in metrics. I am going to do it. So this is always a tricky syntax. Maybe it's like this. This is very embarrassing. The reason is it's very simple. They have tried like 25 approaches on how to codify this for loop, and I was in a private preview, and since then I messed them all up in my head. But as all people that actually, are able to do good demos, I did a thing. I made a file that's completed. There it is. Yes. And for the people that know Python, yes, this looks a lot like a Python comprehension, which is actually the reason this syntax was chosen. And what you see here is I can now mix values that come from the array, and values that come from other places of the template. And the final thing that I wanted to show, you can see here, is that I can do things like string interpolation. Using a $sign and then curly braces, I can do string interpolation. And I can, for example, use that to change the names of my resources between different environments. There's a lot of debate about whether that's a good practice or not, but it's possible. All right, looking out at the time, I think I'm running almost as close to overrunning as how much later we started. So I kind of want to wrap up the demo, unless there are very, very important questions right now. So again, getting value for money for the presentation that I bought. So a little bit of a recap. What you've seen how we can use variables within our files to not repeat ourselves too much. You've seen parameters, how we can specify values from the outside to our templates to make our templates reusable in multiple contexts. One thing you haven't seen, because I always forget it, that's why I created this slide, is outputs. One of the things that you can do is, parameters is pass values into the template deployment. With outputs, you can pass values out of the deployments to the caller. So for example, if you have a pipeline where you want to automatically deploy your app service your app service code to the app service you created, you can output the name of the app service as part of your deployment, and then chain a new task in the pipeline, so you don't have to hard code the name of the web app, but just get it out of the deployment. And the syntax is actually very similar to what you have seen from variables. You can say output, my output var, which is going to be a string, is going to be, let's say, app service.name. And now I can chain other things after the deployment of my template. You have seen functions, for example, a resource group, but there's also one for subscription, and there are like 40 or 50 other functions that you can use for string manipulation, comparisons, expressions, Boolean operations, and all kinds of things. You've seen how you can reference existing resources or other resources in your file with ease. You've seen how you can use modules. Modules really enable you to create complex architectures without having complex files. A very common approach I see is that having one resource per file and then grouping a number of module calls for all those resources in one file and then orchestrating that over a third file is a very common approach which allows you to deploy, let's say, 7 times 7 is 49 resources in a very understandable and clean organization of files. You've seen how you can use loops and conditionals. And here I want to put in a little bit of caution. Remember that I talked about templates as being declarative, which means that if I deploy the same template 20 times and I don't change anything in the deployment, nothing changes in Azure. If I change something in the template, it will be updated in Azure. If something updates in Azure, but I don't change in the template, it will be reverted in Azure. It's all fantastic. However, if I start putting in things like loops and conditionals, I can make very complex conditions on whether to deploy a resource or not, or to change a resource or not, which makes the outcomes of my deployments less predictable. And the reasoning that whatever I do in test will also happen in production can be more and more difficult to uphold. So this is a two-edged sword. That being said, please do try this at home. So funny story, this was a free animation. Any questions? Yeah.
Can we reference modules from different repositories as well?
So the question is, can we reference modules from different repositories locations? Yes and no. So if you want to do it on your local computer, you have to reference it by path. And that means that on the build agent, you also have to reference it by path. However, for example, you can create a ACR, Azure Container Registry, and then upload modules there and reference them from Bicep files. There is a specific syntax for that, and that's possible. You can also create what are called template specs, which are ARM templates that you host as a resource and reference those from a Bicep file. So there are different techniques available, which is a great bridge to a plug. I've written a book about this. I didn't do it alone. I did it together with Erwin Staal and Eduard Kelholz here in the second row. Thank you very much for bearing with us. A lot of these topics are covered in that book. Basically, everything that we could find that relates to Azure native infrastructure as code, we've written about in the book. If you're interested in with the code you see on the screen, you can get a 35% discount. Doesn't have to be today. It's also valid tomorrow, in a week, and in a month. But do buy the book. However, if you're like me, I have 3 discount codes that give you 100% off. So if there is anyone interested in that, come find me after the talk, and I will find some way to divide them among everybody that's interested, if there are more than 3 people. Please do try this at home. I'm very enthusiastic about Bicep. It really saved my teams a lot of time compared to ARM templates. Enjoy them. Thank you for your attention and have a great day.